Hey guys, so today we're going to be calculating acceleration. So we'll have a new formula. So it's going to be really similar to, in some ways, to calculating our velocity, but not. So acceleration is the changing of the speed of an object. So this means it can be either speeding up or slowing down. Okay, so since acceleration tells you speed, remember how with velocity, positive and negative had meanings? Same thing here. So in this case, when we're speeding up, that'll be a positive acceleration. Slowing down will be a negative acceleration or deceleration. Okay, so here's our two formulas, and this one is just the exact same as this one, except for, remember, delta V is change in velocity and it equals v2 minus v1. So put v2 minus v1 in for delta v and you get this formula. So two formulas that are the exact same. Okay, where, and then just defining our variables like we do. So A is your acceleration. And we'll talk about its units in a second. Your delta v is your change in speed. Or velocity. And remember, speed is in meters per second. Over here, our is the same, but v2 is our final velocity, final speed. v1 is our initial speed, starting speed. Once again, both of those with units of meters per second or kilometers per hour or whatever. And delta t for both of these formulas is, of course, change in time. And since we're using meters per second here, it's in seconds. Okay, now we already talked about acceleration being able to be positive and negative, and it just tells us the direction. So whether we're speeding up or whether we're slowing down. So remember, positive means I'm speeding up. Negative means I'm slowing down. I almost said speeding down. So slowing down. Okay, now the units for acceleration. So finding the units for acceleration, just like how with when we were dealing with velocity, velocity is distance over time. So we could figure out the units for velocity is if distance is meters and time is in seconds, my velocity will be meters per second. We can also use this formula to figure out what our acceleration units will be. So acceleration is a speed over a time. So the the units for speed or velocity are meters per second, and the distance for time are seconds, the unit for time are seconds. So we get a meter per second, which makes sense. So with velocity, it was however many meters we were going in however many seconds. With acceleration, it's, okay, what's our velocity per second? So how is our velocity changing per second? Okay, so a meter per second, which if we just simplify a little bit, so a meter per second divided by a second. So remember, you're dividing by something, so multiplying by the reciprocal. So we get a meter per second squared. So the units for acceleration are meters per second squared. Okay. So our first example, we have a particularly powerful car that can accelerate from 0 to 100 kilometers an hour in 6 seconds. What's the average acceleration of the car? So just like with our velocity problems, we start off with our givens. So what are we given? So taking a look at the question. So accelerate from 0 to 100 kilometers an hour. So those are speeds. So here I'm starting at 0, so that's my v1, ending at 100 kilometers an hour, so that's my v2. In 6 seconds, that's a time, and I'm looking for what is the average acceleration. So I'm looking for A. So writing those down, my initial velocity is 0. My final velocity is 100 kilometers an hour. So 0 kilometers an hour and 100 kilometers an hour. And my time is 6 seconds. And my acceleration we are looking for, we don't know. Now, before we go any further, we need to make sure that we have compatible units. So we will need to change units if we need to. Now, taking a look, I have seconds and kilometers an hour. If I sneak a peek back, we are going to need to have units of meters per second squared. So we are going to turn that kilometers an hour into meters per second. So kilometers per hour into meters per second. I'm just going to rewrite this as kilometers per hour like this, so that I can start playing my unit analysis, my unit canceling game. So changing kilometers to meters, so kilometers on top, kilometers on the bottom, that will reduce. And changing my hours, so hours is on the bottom, so hours on the top, into seconds. So in 1 kilometer, there's 1,000 meters, and in 1 hour, I have 3,600 seconds. And we end up getting, so 100 times 1,000 times 1, get 100,000, divide by 3,600. Kilometers reduces with kilometers, hours reduces with hours. I'm left with meters per second. And we end up getting 27.777, so 7 repeating, meters per second. So we have meters per second. 0 kilometers an hour is also 0 meters per second. So there isn't really anything we need to do there, and time is in seconds, so we're good. Now we can move on to our second step, which is writing out our formula. So our formula is A equals V2 minus V1 over T. So V2 minus V1 over T. Now it's already solved for A. A is already isolated, and that's what we're looking for, so we can just sub in. So substituting our values in. So V2 is that 27.7 repeating meters per second minus 0 meters per second divided by 6 seconds. Now here's the thing, don't just put 27.7 into your calculator, because you're going to get something that is not as accurate. So this answer right here, this 27.7 repeating meters per second, needs to be kept like that in your calculator. So keep all those sevens. Now instead of writing 27.7777777 into your calculator, you can just remember leave that answer, and then you'll end up just dividing it by 6. So 27.7 repeating divided by 6, and you get 4.6296 meters per second squared. Now taking a look at our significant figures. So here we do have 3. In your sheet, there is a decimal there. And here we do have 2. So 1, 2, least amount of sig figs. And we will round this to 4.6 meters per second square is my acceleration. So what this number means is that for every second, because remember our units for acceleration are meters per second, which we just shortened to meters per second squared. So for every second, we are getting 4.6 meters per second faster. So for every second, we get 4.6 meters per second faster. So at 0 seconds, we're going 0 meters per second. At 1 second, we would be going 4.6 meters per second faster than that, so 4.6 meters per second. At 2 seconds, we would be going 4.6 meters per second faster again, so for every second we get 4.6 meters per second faster, so 9.2 meters per second. At 3 seconds, we would be going 13.8 meters per second. At 4 seconds, we'd be going 0.4 meters per second. 5 seconds, going 23 meters per second. And at 6 seconds, which is what we have in our question, we'd be going 27.6 meters per second, which is basically what we started with. So keep in mind, we are having to round to significant digits. So this number is close enough, 27.6 and 27.7 repeating meters per second, close enough. We have a race car driver. She is accelerating at an average of 2.5 meters per second squared. So that right there, starting to do my givens, what's going on here, is an acceleration. So meters per second squared, those are the units for acceleration. For 1.5 seconds, that's a time. So what is her change in speed? So I am looking for change in speed, so delta V, at the end of those 1.5 seconds. All right, so givens. We have an acceleration of 2.5 meters per second squared. We have a time period of 1.5 seconds, and we are looking for a change in speed. Here's our givens, now our formula. So our formula is A equals delta V over delta T. So I have a problem here. I have it solved for A. I need to solve for delta T. Or sorry, delta V. Oh my goodness. Okay, so solving for delta V, we need delta T off the side. So multiply, reduces, and we get delta V equals A delta T. And now we're solving for delta V, so we can substitute in. So 2.5 times 1.5. So 2.5, and if I just put my units in here, you do not have to. 0.5 seconds. We'll see that seconds cancels out up here. One of those seconds cancels here, so we get meters per second, which are our units for velocity, so we're good. And then 2.5 times 1.5, we get 3.75 meters per second. Taking a look at our significant figures, we have 2 here and 2 here, so I need to cut it off after 2. So cut off, take a peek over, and we get delta V equals 3.8 meters per second. Okay, the other way that you can do this is if you are having problems with isolating your variable, you can always just substitute in and then isolate. So if we do that, dealing with numbers, so A is 2.5 equals V over 1.5, then we're just dealing with numbers, and some of you just have a better time with that. So V divided by 1.5, I will have to multiply by 1.5. So multiply both sides by 1.5. And then 2.5 times 1.5, we get the same answer. So V equals 3.75, which we will then round to V equals 3.8 meters per second. So you do get the same thing. If you would prefer to just deal with numbers and not deal with letters, feel free to do your questions this way. So example 3, we have someone moving at 1.8 meters per second near the top of a hill to get a pail of water. 4.2 seconds later, she's traveling at 8.3 meters per second. And what is her average acceleration? Okay, so givens. So she was moving at this speed. Now she's moving at this speed 4.2 seconds later. So that's definitely a time. Here is what we were originally moving at. So our first speed, here is our second speed, what we were moving at 4.2 seconds later. And we are looking for our average acceleration, so A. So our givens, V1 is 1.8 meters per second, V2 is 8.3 meters per second. Our time is 4.2 seconds, and we are looking for A. So next step, writing our formula. So A equals V2 minus V1 over T. So it's already solved for A, so we are going to just substitute in. So V2 is 8.3, V1 is 1.8 divided by 4.2. So first off, we should have checked. Yes, we're in meters per second and seconds. Okay, our units are all good, and we're good to substitute in. Okay, so 8.3 minus 1.8. Remember, when you're doing this in your calculator, if you're going to try and do it all at once, put this in brackets, or just figure out 8.3 minus 1.8 first and then divide that by 4.2. So 8.3 minus 1.8 is 6.5 divided by 4.2, and we get 1.5176 meters per second squared, and sig fig. So 2, 2, and 2. So we will have to cut off after 2, taking a peek over. It's just a little 1 there next to the wall. So we get an answer, of 1.5 meters per second squared for our average acceleration. Okay, so I didn't put the units in this time. You can, to simplify your work, leave the units out as long as you have them correctly in your givens. When you substitute them in, you should be okay. So always somewhere check your units. And since I'm dealing with acceleration, I know my units will be meters per second squared. So meters per second squared is our acceleration. Example 4, we have a bus with an initial speed of 12 meters per second. It accelerates at 0.62 meters per second squared for 15 seconds. What is the bus's final speed? So givens. So initial speed, so that's V1, accelerates at this, so meters per second squared would tell me that it's an acceleration even if it didn't say it in the question. So acceleration and seconds time. I'm looking for V2 this time. So V1 is 12 meters per second. Our acceleration is 0.62 meters per second squared. Time, 15 seconds. V2 we are looking for. So formula, A equals V2 minus V1 over T. Now I'm going to do this both ways. So the first way, we're going to actually solve for V2 first, and then the second way, we're just going to take our equation and substitute in and choose whichever one you like best. Okay, so solving for V2. First off, V2 minus V1, they're both upstairs. T is downstairs, so T is farther away. Let's get rid of T. Okay, so T is gone. And we get, and I'll just write it alphabetically, AT equals V2 minus V1. Next step, solving for V2. So it's V2 minus V1, so add V1 to both sides. Add V1. Ay, caramba, what did I just do? There we go. So V1's gone, we're left with V2 equals AT plus our initial velocity. Now solve for V2 so we can substitute in. So A is 0.62, T is 15, and my velocity, initial velocity is 12. Okay, so multiplication before addition. So doing this first. So 0.62 times 15, and I get about 9.3, then plus 12, we get 21.3 meters per second. Now, significant figures. We have 2 here, 2 here, 2 here. So rounding to 2. Take a peek over. And we get our final velocity is 21 meters per second. Now, the other method, instead of, if you don't like dealing with letters, substitute in your numbers and then deal with those. So our acceleration is 0.62. We're looking for v2. We don't know what that is. That's like our x minus v1, which is 12, divided by our time, which is 15. Okay, now, same thing, 15's in the bottom. Okay, so these two are up top, 15 in the bottom is farthest away, so multiply both sides by 15. And we get 15 times 0.62, which is 9.3, equals v2 minus 12. Okay, and then v2 minus 12, so minus 12, the opposite is plus 12, gone. And we get v2 equals 9.3 plus 12, which is 21.3 meters per second, or to the proper significant figures, 21 meters per second. So same thing. So it's just however you prefer to do your questions. Last question. Example 5. In a race, a car traveling at 100, and this is once again with a decimal in yours, kilometers an hour comes to a stop in 5 seconds. What is his average acceleration? So picking some things out, car traveling at 100 kilometers an hour, so this is v1, comes to a stop, and I'm going to highlight that, even though it's not a number, in 5 seconds. What is his average acceleration? Okay, so stop doesn't look like a number, but if you're stopped, what is your speed? 0? Yes. Okay, so this is actually our final velocity. Well, anytime you see the word stop in a question, that means 0. Okay, so stop equals a 0. So whenever you're given just one velocity, it means you have probably had a stop there when you have an acceleration question. So just reread the question, see if it does not sneakily tell you that you do have another velocity. Okay, so our givens. So our initial velocity is 100 kilometers an hour. Our final velocity is 0. Our time is 5 seconds. And I want to find my average acceleration. Now, why this is important, we're going to get to in a second. Now, 100 kilometers an hour, and I want average acceleration. I'm going to have to change that kilometers an hour to meters per second. Now, luckily, we've already done this in a previous question, so we can just take a peek back there. 100 kilometers an hour is 27.7 repeated meters per second. Okay, so instead of doing the work again, we already did that. Let's just write it there. Okay, so finding our average acceleration. So v2 minus v1 divided by t. Okay, so it is important in this case to make sure you are watching very carefully how you're putting these numbers in. So v2 is 0, right? Minus v1. So minus v1, which is 27.7 repeating meters per second, divided by our time, which is 5. Now, why this is important is we have 0 minus 27.7 repeating, which is negative 27.7 repeating. Okay, so we have negative divided by a positive, so I am going to get a negative number. So 27.7 repeating divided by 5, I get 5.5 repeating. So 5, 5, 5, 5, just all these 5s. Blah, 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 blah. Meters per second squared. And so 3 to 2 significant figures, I get negative 5.6. meters per second squared. Now, why that is important is, remember that negative means that we are slowing down, which makes sense. If we're going 100 kilometers an hour and then we stop, we are slowing down, not speeding up. So I need to show that mathematically by having that negative number. Now, if you did do this question in your calculator, without like accidentally putting your V1 as your V2 and just doing 27.7 repeating divided by 5, you get a positive number. But if you go back to the question and take a look at what's happening, you should recognize that you should be getting a negative answer. So go back and just check your work. In all of our other examples, we were speeding up. So here, positive acceleration, so speeding up. Here, speeding up, so going 1.8 to 8.3. Here, positive acceleration, so speeding up. Whenever we have a negative acceleration, that does mean we are slowing down. Your assignment is you need your textbooks, turn to page 388, and you're going to be doing numbers 1 to 10 and then 12 to 14. So basically 1 to 14 with omit number 11. Okay, so 1 to 10, 12 to 14.